On behalf of the University of Bath, Biotriz Limited and First Cut Media present this video course on inventive problem solving. This film series will teach you how to solve problems using our unique methods. So, let's start our journey to invention.
Everybody knows that in this world we can observe things which are possible and very predictable, such as this ball falling down. Probable things like this die falling on 6. But we can also observe the impossible. Isn't it amazing how swiftly technology develops? Like this iPad. I mean, how many Victorians would have thought that today we'd happily be using computers and mobile phones, aircraft and space stations? Many things seem impossible today, but who knows what could happen in the future? Perhaps these things which seem impossible are only impossible for the moment. We should never consider anything to be impossible or unachievable. Never say no. These days we use a clock like this to tell the time, but in the past we used an hourglass. But is it possible to create an hourglass where the sand, instead of going down, goes up? Never say no, because if we make the right conditions, we can do it. Have a look at this magic hourglass. In this one, the sand granules are actually moving upwards. You see, just a moment ago, a challenge we thought was impossible has now been achieved. Can we carry water in a basket? Never say no. By freezing water, we can overcome the obstacle. Problem solved. Can a child lift a grown man in the air and hold him there for a long time?
I bet I can.
Really? Go on then, show me. All of these solutions we know from our childhood, such as the principle of the seesaw, which these two boys are demonstrating now. Are you having fun, boys?
Yeah!
So, what made us think we couldn't do it? Why did we forget these principles? Psychological inertia is one of the biggest obstacles that any inventor or engineer has to overcome. This video course is here to help you look for unexpected but existing solutions. You will be able to invent seemingly impossible things. Here's a bit of history for you. Triz was introduced by Genrikh Altschuler. He was a patent engineer in the Russian Navy. Thousands of different patents went through his hands, and he noticed that similar types of solutions appear in completely different inventions. The strongest patterns of engineering solutions he called inventive principles. These principles can be called the models of inventive solutions, and you will learn how to apply them and how to generate solutions. Altschuler noticed that often problems are similar in different domains, from mechanical engineering to management. At the core of any problem, there is a conflict between what we want to achieve and an obstacle that appears along the way. You will learn more about this in the 5th film about conflicts and obstacles. Altschuler also discovered that each type of problem has its own set of solution models. That was the first equation for an invention. It helps you to choose which inventive principle is better to use for your problem. Now, innovation is no longer based on sudden inspiration or raw talent, meaning that everyone can be taught to be a genius inventor. When we want to solve a problem, we are usually looking for a single solution which is perfect to implement. Even if we generate lots of ideas, we still need to choose just one. Generating numerous solutions is not efficient and may be dangerous in some situations. It is therefore better to target the ideal solution from the beginning. You will learn more about this in the film about the ideal final result. Have you ever wondered why great inventions are so breathtaking? It's because they impress us with their elegance and simplicity. Let's have a look at this self-sealing bottle. Back in the 1870s, carbonated drinks such as cola or lemonade were very popular, but the problem is sealing the bottles. If we put a cork in, the gas pushes the cork out. So in the case of champagne, we have to put a wire cage over the top of the cork to keep it in place. This makes them hard work to make and also pretty difficult to open. However, with these, you'll see the bottle has got a glass marble inside it, just like this. And in the neck of the bottle is a rubber seal. Bottles like this were placed in filling pumps like this. If we turn that the right way up, the carbonated drink is then pumped under pressure through here and fills up the bottle. When we turn the bottle back over, both gravity and the gases in the bottle push the marble right up against the sealing ring. When we take the bottle out, assuming that this bottle has then been filled, the gases keep the marble forced up against the ring. We therefore have an airtight container. Bottles like this seem pretty old-fashioned, but are still being produced today. These drinks from Japan work off exactly the same principle. Here's the empty bottle, and here's a full one where the marble is being pushed up against the seal. In the film about resources, we will look at how we can use the main obstacle as a source for the solution. When you complete the TRIZ course, you will be able to overcome various obstacles and resolve your problems rather than giving them a quick fix. You will be able to find the best solution readily and easily instead of using random trial and error methods which are costly to time and resources. The TRIZ course is unique because it offers you tools to use in any situation. The next episodes will look at the nuts and bolts of this exciting method.